Yeah, good morning, everybody, and afternoon, some situations, and great to be here. I wanted to kind of start off with the concept of wouldn't it be a great idea if we didn't have to drill any more oil wells? And I'm going to kind of let that sink into your head as we go through what we're presenting here. And Gravitas Infinitum, and this is the beginning of our planet plan. And Alan is helping me with the slides here. So Gravitas Infinitum is an impact holding company. And Gravitas Carburetora is the carbon and plastic capture to biomaterials. And then T4L is the subscription to electric vehicles. And that's being another business that's pretty exciting with Tesla and Nissan and others. But Alan is working through here. There we go. So essentially, there's enough exposed carbon for all of humanity and the planet if properly captured and recombined. And what we're trying to do is, essentially stop three slow-moving catastrophes from happening. One being global warming, this plastics pollution, and also the financial failure of the petroleum industry. That's millions of jobs around the world. Certainly something that there's an opportunity for an evolution for that entire industry, and we can get into that a little bit later. Everybody uses plastic. There's no way to just kind of end it, and it's not about necessarily recycling the plastic, but we can recycle the atoms. And so there's a really exciting, process there. But we can stop exposing planet-trapped carbon from entering the atmosphere. And, we can introduce a bio-crude to the upstream petroleum industry and also capture carbon from recombined atmospheric carbon, as well as the waste plastics carbon as well. And this is just a bit of a simple outline of taking those giant plastic bales. And there's no need for separating or washing or cleaning. You're essentially utilizing it for an energy source, combined heat and energy capture. And then we've built out high density bio facilities that essentially are vertical farms, high density vertical farms, and processed out of that is bioplastic crude, biopolymer crude, and bio oil crude. Essentially, all of this process replaces and displaces carbon from oil wells. And it's an elegant system that allows us to basically, bio-extract and air mine, crude supplies. And we're coming in at, and this is, for an oil business and the entire petroleum industry, they have exploration costs, they've got drilling costs, and they have extraction costs. And we compare about half the cost, while at the same time eliminating plastic waste and continually sequestering and reusing that carbon. We're going to get into the environmental attributes and our ESG metrics. I'll let Alan get into some of the operational metrics that are pretty exciting. But essentially, because we're all kind of thought leaders in the sustainability space, we've got a pretty exciting presentation here, because each one of these little biocarbon wells eliminates 45,000 tons of plastic waste annually. It captures 282 tons of carbon a day, and 13 million gallons of water is bioremediated per day. So that's somewhere around 5 billion gallons a year, and about 1.2 million pounds of raw biomaterials that can be vectored out to all sorts of uses. In fact, about 150% greater usage than petroleum because of the fiber strength of the biomass. We're a zero waste and closed loop process, enabling guilt-free plastics and renewable energy. Some great social components on the S of the ESG. Each facility is about 100 construction jobs and 100 permanent jobs, really focusing on areas that we can hire minority and underprivileged employees with higher than living wage salaries, and creating a great culture, because honestly, it's more fun when you know that you're doing good for the world and have a purpose. Obviously, I think one of the problems initially in the the sustainability space was it was a compromise with profitability, but that's not the case. It doesn't have to be the case. We target greater than 80% gross margins on all the products. Investors obviously very well taken care of, but we also have a number of currencies because we're also working with tax credits, carbon credits, plastics capture credits. There's some really interesting credits out there, and these facilities can last 20, even 40 plus years with proper maintenance. So this is a really amazing infrastructure play, and also because when you're drilling for carbon in earth-trapped wells, you have a steep decline rate after a relatively short period of time. There's no decline rate here. We have consistent producing, production for decades. We don't really measure in our models our incentives, but we expect about a 30% return on our capex from just some of their environmental benefits that we're laying out here. And we're kind of discounting our pricing dramatically to just show on a very conservative basis that this can be extremely profitable. And also, if there's any major financial catastrophes, that we would still be able to build and show that this infrastructure can be basically modularly and extensively, placed around the world. In each one facility, about 100,000 square feet, creates about $200 million of local impact, from on an annual basis. And we're focusing initially in the United States. The B impact, I don't know, not many people here are familiar with B Corps, but a lot of people that we speak to, they don't really know that space. But B impact, B Corps is a measurement of, they create a metric to allow people to show various aspects of impact. And we came out, we're still in final stages of verification, but the leading score in the world is 131. We came out on our initial score of 224. We also completed the United Nations Sustainability Development Goals, and across all 17 global goals came out with a 96% score. The average benchmark in the United States, unfortunately, is 37%. There's a lot of room to grow there. Obviously, the United Nations is more like 193 signatories, and the United States being one of them. It's good to just show that we are supporting the United Nations efforts to the global goals. And I'll let Alan get into the operational attributes, and then we can kind of field some questions and some thoughts across the the leadership here in the group.
Great, thank you.
We don't hear you, Alan.
I just asked them to unmute.
Yeah.
Yeah.
No, not yet.
Can you hear me now?
There
Oh
we
yeah,
go.
Roger.
Okay, good.
And also, Alan, if you wouldn't mind just giving some background, because I'm sure I blew some people away with some of the things I said, but give a little bit about your background, I think would be helpful as well.
Well, I've been doing a lot of deals. Raised over $3 billion in my life. We've got many software platforms that we've built, some infrastructures, and we started Gravitas Infinitum to be a good company to start with. And the whole approach is build a foundation of a good company. Take these principles of ESG, SDG, and just build on them. And it's not that hard once you start that way. So we decided to take on a really hard problem, replacing oil wells. So here we go. We take waste plastics, we thermally mechanically convert them. And you guys have seen the piles of plastics. The output from that, we turn into light, we add water, minerals, and captured CO2. The biofactory is a factory that grows plants, and it grows them very quickly. We are utilizing the hemp plant because it can grow from 1 gram to about 10 pounds in a month. It also puts out about 1,000 different molecules. This chart will give you an idea of what it can output. We broke our business into 3 areas. Area 1 is waste plastics, energy, water handling. Area 2 is the high density biofactory. And area 3 is the processing and refining. All of these technologies are proven, but never been chained together in this manner. You can see our attributes in the second line of data here. And we're doing complete elimination of the waste plastics of all types. And then we recombine those by using the plants into a multitude of biomaterials. And at the same time, it's the most efficient carbon sequestration method available.
I just want to interrupt real quick. I'm gonna give you another 10 minutes because we have another speaker that couldn't make it. So there's no rush right now. Thank you.
Okay, thank you.
Yeah.
This is our cause and effect diagram. Pretty simple. I went through the biomaterials a little bit, but here's our core competency is these biocrude materials. There's thousands and thousands and thousands of downstream uses. Our primary material buckets, biofiber for plastics, paper, fillers, bio-oils, and biofuels. So what does a plant look like? This is a small pilot design fits in 40,000 square feet. And it puts out about 1.5 million pounds of materials a month. And we basically merged Amazon logistics with hydroponics. On the front end, we merged microwave pyrolysis to eliminate the plastic waste. This is what one of our modules looks like. It's about $100 million invest. And it puts out 34 million pounds of biomaterials. We put 6 of them together in a campus, and we've got a $600 million facility that replaces probably 30 oil wells. We're a full believer in the circular economy. Waste plastics in, renewable energy, biomaterials, and then closing the cycle with some guilt-free plastics. This is our monetization stack. The area where we're working on creating credits, and we're working on a cellular climate credits system that also takes into account the materials that are output. Today, we're a very interesting model. We have 6 carbon credits and renewable energy credits right out of the gate. And we compare to the basic bespoke products that are planting trees that are one-time shots. To give you an idea, one tree takes 100 years to sequester 1 ton of carbon. One of our plants is doing 282 tons a day. We're continually producing credits. They're measured and verified every minute, and we expect to support a subscription model on credits. This is what our credits matrix look like. We have these marketable credits. There's tax credits, renewables, biomaterials, and then we're working on something called a super credit. The super credit is where we combine carbon credits with biomaterials. So a company like Coca-Cola buys our bioplastic. They get a carbon credit with that also. Scott, that's pretty much the overview. Any questions?
Scott, you're on mute.
Sorry about that. Thank you. Thank you very much. I have to say, can you guys hear me okay?
Yeah.
Yep.
Okay. I have to say what's really fascinating about this, and when I had called you and we did a longer presentation, it was about maybe 35, 40 minutes. I thought it was a little bit over my head, but then looking back and taking a step back, what's really fascinating about this technology is that it's truly circular because it's tackling the water issue with water sustainability. It's tackling the plastic crisis. It's creating jobs. I just think this is a really interesting map. I had a question. I'm sure other people do as well. I'm not really clear from my lens, and this isn't my expertise, but the carbon credits, how does that work on the back end? You know, when you're giving carbon credits and you have that SDG score that's there, how do they calculate that on something that's a project that's scaled out? That's what I'm still not really clear about. Like how they come up with that score. You said you had one of the highest score, I believe, in the US or North America for this. Maybe you can help me to understand that, or help the people on the call understand as well. You know?
Yeah, that was a B impact analysis.
Oh.
They look at about 300 different items. It's an audit of everything you do. Because we're eliminating plastics, remediating water, and carbon capture, we end up just sort of knocking it out of the park. Where a carbon credit originator, which is really rare. So that's why the scores doubled up.
Yeah, we may have some questions too from other attendees. What's the biggest objection that you see from the oil industry right now? I mean, will they embrace this, or does it compete with what they do right now? You know, it's
Well, they
Well, that's
realize
why
they have a pretty heavy carbon liability that they're trying to get out from underneath. And so we're giving, this is, you know, essentially an escape hatch. But it's just great that, you know, at least there's common ground for sustainability thought leadership, as well as the oil and gas industry, because kind of, you know, it's created a bit of a you know, a war ground, but there is opportunity to work together to allow this oil and gas industry to actually transform. But at the same time, it's going to be, you know, it's going to be a costly transformation, and they're realizing they've got quite a liability on their hands.
a couple other questions here that are coming in the comments. Sorry, there was someone speaking. Sorry.
That was me. I apologize. I'll put myself in line for the next question here.
No
Sorry.
problem. Eileen's asking from AB InBev, how does the carbon sequestration happen?
Through photosynthesis.
And what type of plastic are you using in the process?
The waste plastics can be any type.
Okay, well, grades, yeah. Okay. What is the status? Is it in pilot? Or are you in production? How do you find the funding from idea to pilot to initial project is another question. So
Yeah,
that's
we
a
get
tough
that
question
all the time.
yeah.
How old is photosynthesis?
Older than us.
That's
Yeah, so we start with that conversation on that. And then we show where all the technologies are proven. We have certification on them. Some of them are 40 to 50 years old. What hasn't happened is everybody put them into a combination we have. And so that's a software process overlay that needs to be proven. We've self-funded this.
All right, and I have one more question just for time's sake, because we have another presentation after this. And we're also going to have questions right before the 12 o'clock, so we can come back. How do you separate the bio-based materials in today's recycling streams in your second life cycle?
So it's all done mechanically. A lot of centrifugal separation.
Mm-hmm. And another question here, I just have to ask this: does contamination affect your yield?
No, it doesn't. We work in a semi-sterile environment. There's no dirt. It's very, very clean.
And which plastics, this is the last one, I can't stop. Which plastics have the highest energy value in your process? Have you considered recovering the high value plastics like 1, 2, and 5 and converting the rest?
We don't care what shows up at our doorstep. If somebody wants to recycle reprocess the plastics that are easy to reprocess, we're fine with it. The bigger problem is the 97% that goes into the landfill.
All right.
Can I give some perspective? I don't know if I'm the only person from the oil industry or that crosses over from the oil.
Oh, sure. Who is this?
This is Charlie Mummert. So if
hi, Charlie. Hi.
you want, I can give you a little perspective on that. And Tyler and I actually had some calls with one of my partners who is 100% in the oil and gas space. So I can tell you from a pivoting perspective, I can give you a little background on why there are incentives for companies to do this. A little background on the shale game and why this could be and is advantageous to a lot of people.
Yeah, just keep it to like 3 minutes if you can, if you don't mind.
Not a problem. I'm
All
going to
right,
break it
thank
down
you.
quickly. I'm going to tell you, just give you a little homework on this quickly. Tyler is correct that in terms of you lose yield very fast, but that's specifically, I'm going to say, do some research on shale. Shale is sort of was the biggest Ponzi scheme you could think of possibly that wasn't called a Ponzi scheme. The reason we had so much influx of oil, quote unquote, in our reserves was due to shale. It takes extreme higher volume of shale to actually make an oil that's actually has enough terpenes in it that it's actually used for that can be used. So with that being said, you have a lot of time, right? You have a lot of companies right now. I can say right now we have all of our wells capped in West Virginia, and we're sitting on 1 million acres in Canada that we're probably never going to drill. So ultimately, as a company, are we going to try in uncapped wells? Probably not. But I can say what this is an advantage to the oil industry, and I can tell you there's people playing games, but it's not truly closed loop. And I'll give you an example. Crusoe Energy, they're heavily invested by Peter Thiel and the Winklevoss brothers. Well, they came to a short-term solution to say, hey, let's offset our carbon. So what they would do, they come in with these pre-set up systems, they hook them up, and instead of burning off your gas that literally costs more to move than burn off, they would hook it up into a Bitcoin mining. Well, at some point that is going to close itself off and it's going to basically sound good. But when we try to get Crusoe on the phone to put their systems in any of our wells, never a call back. So not really sure where their revenue stream is, if it's just more of a private equity play. But ultimately, there's so many small time players in the oil and gas field right now that, I can say personally, in the last month, we've laid off 250 people and they're not getting those jobs back.
Wow.
So we all agree, no one wants to go drill in Gas Bay. No one wants to go drill in the Arctic. So having something that's actually sustainable, closed loop, is actually truly going to give the opportunity the same way that IBM, if they said, hey, let's make typewriters for life, they'd be out of business. At some point, they had to pivot, right? The same way oil and gas and energy has to pivot. The same way that Formula One had introduced Formula E racing. And because of Formula E racing, now we actually have true private research and development driving electric cars. And you're going to see that, it's already paying off. So that's sort of my quick little perspective coming from the oil and gas, interested in how this works and how we can all come together. Because ultimately, if we keep doing this, we're never going to come to a common solution to the greater good. So that's my
absolutely. Thank you. I'm really optimistic on it. I mean, looking historically at the industrial revolutions that have happened, there's always pain and paralysis before we move forward. And I think there's so much pent up demand for this type of technology. So it's coming, and I really love what you guys do. So thank you, Alan and Tyler.
Yeah.
Thank you.
Good.
You're welcome. Thank you.
So we're going to move to our next presentation here. Just one moment.